So let's start talking about how the periodic table of the elements is set up. It really starts from what is known as the periodic law, which states that there's a repeating pattern or periodicity to the chemical and physical properties of the elements. Okay, so let's take, for instance, helium, which is element 2, has 2 protons. Helium is a gas at room temperature. It is very inert, meaning it doesn't react very much with anything. You have to do some crazy things in the laboratory to get helium to do anything in terms of chemistry. 8 elements later, you have neon. Atomic number 10, 10 protons. Neon is also a gas at room temperature. It is also very inert, doesn't react with anything in nature, just like helium. 8 elements later, we have argon, element number 18. And argon is also a gas at room temperature and extremely inert. This starts what we know is the periodic law. There's a repeating pattern or periodicity. After argon, the periodicity changes from 8 to 18 to 32, but it still holds true. Additionally, we can think about other elements like lithium, which is element number 3. Lithium is a metal, a very soft metal. It reacts very easily, very violently actually with water. It likes to form a +1 ion. It likes to lose 1 electron. 8 elements later, we've got sodium, Na, and with an atomic number of 11. Sodium is also a very soft metal. It is also very reactive. You have to store it in oil because it will react with water in the atmosphere. It also tends to form a +1 charged ion, just like lithium. 8 elements later, we've got potassium with an atomic number of 19. And I bet you can guess it, potassium is another very soft metal, very reactive, reacts violently with water, and also forms a +1 ion when it reacts with water. So what this is, it started off this periodic law started off what we now know as the periodic table. Instead of thinking of these as a row like I wrote it, what we do is we group those elements in columns that show the elements that share the chemical and physical properties that we discussed. So here's lithium, sodium, potassium. Continue on, we'd see rubidium, cesium, and even francium would have very similar chemical and physical properties. Over here on the other end of the periodic table, we found helium, neon, and argon. And just as I said, the pattern would change from 8 to 18 and then eventually to 32, but here's krypton, xenon, and radon, which all would be gases and very inert. So that's why the individual elements are grouped the way they are in a periodic table. They show very similar chemical and physical properties with the other elements in the columns. And the columns we actually call groups. And for the most part, the elements in a group share very similar chemical and physical properties, as we said. The rows of a periodic table are called periods. And once that periodicity switched from, say, sodium to argon, the next element that had a very similar physical property, sort of broke it off and started a new row or new period in the periodic table of the elements. For discussing elements within the periodic table, of course, we're going to want to number the groups and periods. For the groups, as you can see, there's 2 main mechanisms for numbering the groups or columns. There's a very straightforward 1 through 18 system, where we number the groups 1, 2, 3, so on, all the way to group 18, which has helium and argon. Or we can also split this up into what are known as main group elements and transition elements, or transition metals. We can name the first two rows as A, and then continue that with group 13, or 3A. So we've got 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. So 1A through 8A, these are known as our representative elements, or main group elements. The numbering system for the inner 10 rows, or 10 groups, 10 columns, 10 groups in between are known as the transition metals, and we would name or number them with B. So this goes 3B all the way to the numbering system. It changes quite a bit. In this course we won't deal with that a little bit as much, but it goes 3B through 8B, and then there's a couple 1Bs. Okay. But the representative or main group elements numbering system 1A through 8A is really going to start to help us when we start talking about valence electrons shortly. So again, there's two ways to name these, or number the periodic table. We've got A and B numbering system, and then of course 1 through 18. Additionally, some groups have very specific names. The elements in group 18, or 8A, are known as the noble gases. That is because they are very inert, as we said when we talked about helium, neon, and argon. Group 17 are known as the halogens. Group 1, or 1A, are known as the alkali metals. And group 2, or 2A, are the alkaline earth metals. The periods, as you see, are numbered fairly directly, just 1 through 7. 1, 2, 3, 4, 5, 6, and 7. Starting with a new periodic table, we can address some of the other areas of the periodic table. If you see right here, there's a region of the periodic table that has a little bit bolder of a line. I'll highlight it a little bit more. This is the division between what are known as the metals and the non-metals. The metals, or the elements that represent metals, are by far the majority of the elements. All of the elements to the left of that line are metals. The elements to the right of that line are non-metals. Some of the elements that sit on the border of that transition are known as metalloids. They share characteristics and properties of both metals and nonmetals. Silicon is your characteristic metalloid. These are sometimes called semiconductors, and of course silicon is a main component of semiconductors and computer technologies, and that's why the area in California is named Silicon Valley, where a lot of technology companies reside. I previously mentioned the first two groups and the last 6 groups are known as the main group elements, or the representative elements. The middle 10 groups are known as the transition metals. And you'll notice that there's 2 rows at the bottom that aren't labeled with period numbers. And that is because they are actually part of period 6 and period 7 respectively. If you look at the atomic numbers of the elements right here, lanthanum and actinium, it's 57, and the next element, well, the atomic number skips by quite a bit. 57, hafnium's next, and 72. So where'd those 14 elements go? They got taken out and placed down here, essentially just so that we can display the periodic table of the elements a little more conveniently. It should actually be about probably about twice as wide as it is if we put these 2 rows in between lanthanum and hafnium and actinium and rutherfordium. This row down here, or actually both of these rows, are referred to as the rare earth elements. And the individual rare earth elements periods are named after the elements that they immediately precede. So the rare earth elements in period 6 are sometimes known as the lanthanide series because they come directly after lanthanum, and the rare earth elements in period 7 are sometimes called the actinide series because they immediately follow actinium.